Hello everyone, I am Mank and welcome to Simplilearn. Today we will take you through a hands-off lab demo how we can use LSTM model for forecasting in machine learning. Before we start, I hope the screen is clearly visible and the audio is fine. If yes, please type in yes. If there are any issues, do let us know in the chat section so that we can resolve them. Let's wait for some more minutes to let other people join. Until then, let me tell you guys that we have regular updates on multiple technologies. If you are a tech geek in a continuous hunt for the latest technological trends, then consider getting subscribed to our YouTube channel and press that bell icon to never miss any update from Simplilearn. Great. I think we can get started. So in today's session, we will discuss what LSTM model is, and moving ahead, we will discuss what RNN is. After that, we will see types of gates in LSTM models. After covering types, we will see some applications of LSTM models, and at the end, we will do a hands-off lab demo of gold price prediction using LSTM model. Before we move on to the programming part, let's discuss what LSTM model is and proceed further for the same. So what is LSTM? Long short-term memory. LSTM is a type of recurrent neural network that can capture long-term dependencies in sequential data. LSTM models are able to process and analyze sequential data such as time series, text, and speech. They use a memory cell and gates to control the flow of information, allowing them to selectively retain or discard information as needed, and thus avoid the vanishing gradient problems that plagues traditional RNN. LSTM are widely used in various applications such as natural language processing, speech recognition, and time series. So moving ahead, we will see what is RNN. RNN are a type of neural network that are designed to process sequential data. They can analyze data with temporal dimensions such as time series, speech, and text. RNN can do this by using hidden state passed from one timestamp to the next. The hidden state is updated at each timestamp based on the input and the previous hidden state. RNN are able to capture short-term dependency in sequential data, but they struggle with the capturing long-term dependencies. So after understanding what is RNN, moving forward, let's see types of gates in LSTM model. So there are three types of gates in LSTM models: the input gate, the forget gate, and the output gate. The input gate controls the flow of information into the memory cells. The forget gate controls the flow of information out of the memory cells. The output gate controls the flow of information out of the LSTM model into the output. So the input gate decides which information to store in the memory cell. It is trained to open when the input is important and the close when it is not. The second one is the forget gate. The forget gate decides which information to discard from the memory cell. It is trained to open when the information is no longer important and close when it is. The third one is the output gate. The output gate is responsible for deciding when information to use for the output of the LSTM. It is trained to open when the information is important and close when it is not. The gates in an LSTM are trained to open and close based on the input and the previous hidden state. This allows the LSTM to selectively retain or discard information, making it more effective at capturing long-term dependencies. So moving forward, let's see what are the application of LSTM models. Long short-term memory LSTM is highly effective RNN that has been utilized in various applications. So here are few well-known LSTM applications. The first one is language simulation. Language support vector machine LSTM have been utilized for natural language processing tasks such as language modeling, machine translation, and text summarization. By understanding the relationship between words in a sentence, they can be trained to construct meaningful and grammatically correct sentences. The second one is voice recognition. LSTM have been utilized for speech recognition tasks such as speech to text transcription, and command recognition. They may be taught to recognize pattern in speech and match them to appropriate text. The third one is sentiment analysis. LSTM can be used to classify text sentiment as positive, negative, or neutral by learning the relationship between words and their associated sentiment. The fourth one is time series prediction. LSTM can be used to predict future values in a time series by learning the relationship between past values and future values. The fifth one is video analysis. LSTM can be used to analyze video by learning the relationship between frames and their associated actions, object, and the scenes. And the last one is handwriting recognition. LSTM can be used to recognize handwriting by learning the relationship between images of handwriting and the corresponding text. So, after seeing application of LSTM, so let's move to the programming part. So first we will open command prompt to write command to open Jupyter Notebook. So here we will write Jupyter Notebook. Okay. Jupyter Notebook is open. This is the UI of Jupyter Notebook. So here we will go new Python 3. This is the Python kernel UI of the Jupyter Notebook. So now, so first we will import some major libraries of Python which will help us in analyzing the data and prediction and all. Okay. So here we will write import numpy as np. Second, import pandas as pd. Third one is import matplotlib dot pyplot as plt. Fourth one is import plotly dot express as okay. So these are some basic libraries. So like from sklearn dot preprocessing import max scalar. Okay, then from sklearn dot model selection import train test split. This is used for like dividing the data into training and the testing. Okay, split. Then from sklearn dot matrix import solute percentage. Okay, then some import TensorFlow as TF. Then from Keras import model. Then from Keras dot layers import input dense dropout. Then from Keras dot layers import the major one LSTM. That, is so we will do the goal prediction. Okay, we have the data from 2020. Okay, we have data from 2013 to 2023. Like, okay, there is one error. Okay, this is Keras. Yeah, so I will change it to gold prediction using LSTM. Okay, let's name it. Yeah. So first, NumPy. NumPy is a Python library used for working with arrays. It also has a function for working in the domain of linear algebra and matrices. It is an open source project and you can use it freely. NumPy stands for numerical Python. The second one is Pandas. Pandas is a software library written for the Python programming language for data manipulation and analysis. In particular, it offers data structure and operation for manipulating numerical tables and the time series. And now Matplotlib. For Python and its numerical extension NumPy, Matplotlib is a cross-platform data visualization and graphical charting package. As a result, it presents a strong open source suitable for MATLAB. The APIs, application programming interfaces for Matplotlib, allow programmers to incorporate graphs into GUI applications. Okay, then there is sklearn, scikit-learn. So scikit-learn is a free software machine learning library for the Python programming language. It features various classification, regression, and clustering algorithms, including support vector machines, random forest, gradient boosting, k-means, and dbscan, and is designed to incorporate with Python, numerical, and scientific libraries like NumPy and SciPy. Okay, then we have dense. A dense layer is a layer that is deeply connected with its preceding layer, which means the neurons of the layers are connected to every neuron of its preceding layer. This layer is most commonly used layer in artificial neural networks. Okay, then there is LSTM. Okay, LSTM stands for long short term memory layer. You know, we have discussed in the starting of the video what is LSTM, what is RNN, and how types of LSTM and some application. Okay, so LSTM stand for the long short-term memory layer, which created in 1997. This layer use available constant and runtime hardware to gain the most optimized performance, where we can choose the various implementation that is pure TensorFlow or CUDNN based. Okay, so now what is TensorFlow? TensorFlow is a free and open source software library for machine learning and artificial intelligence. It can be used across a range of tasks but has a particular focus on training and interface of deep neural network. Okay, so moving forward, we will import our dataset. So for the reading dataset, we will write df equals to pd dot read underscore csv. Okay, then here we will write gold price dot csv. Okay, so this dataset, gold price dataset, you can download this dataset from the description box below. Okay, dataset is loaded. So now we will see the overview of the dataset. So here we will add df, press enter. So from 2022, like, you know, end of the year of like 2022 till from the 2013. Okay. So as you can see, the data set includes daily gold prices information, including daily open and high and low prices, and the final price of each day, along with the volume transaction and the price changes in each day. Okay, like price, open, high, low, volume charge, change percent. Okay, so let's see now data set basic information. Okay, what I will do, I will for the better visuals, I will here I will write df dot info. Yes. So here all the variables are stored as object. Okay, date, price, open, high, low, volume, or change percentage. Okay, no null count, total value is 2583. Okay, memory usage is 141.4 KB. Okay, so now moving forward, let's do some data preparation. Okay, feature subset selection. Since we will not use the volume and change percent features to predict price, we will drop these two column of features, you can say. Okay, so for dropping them, we will write here df dot drop volume. Okay, then change percent Then axis equals to 1 is equals to true. Okay, press enter. So, okay, there is one error. What's the error? Volume not found in axis. Okay, we will, it's there only, I guess. Okay, V is capital here. Now let's see the data set. See now, we have dropped these two columns, volume and change percentage, data price open, high and low. Got it? So now here we will do some, transforming data and all. So data features is stored as object in the data frame, as you already know. See this object. So first we remove, uh, no, we will not remove right now. So to increase the speed of calculation, we convert its data type to date time and then sort this feature in ascending order. Okay. So for that, I will write here, yeah, date equals to pd dot to date time, then df. Okay, then df dot sort values by equals to date, then ascending equals to true, is true. Then I will write df dot reset, that drop equals to true, t is capital here, is true. Okay, press enter. So now what we will do, I will write here number of num columns equals to df dot columns dot drop this state, then df num calls equals to df num dot replace, comma, here I will write colon, then my rejects equals to true. Okay, then df num calls equals to df num calls dot as type dot 64. Okay, it will be here, right? Press enter. Okay, this place spelling is wrong. Mistake. Capital. C is capital. Yeah. So the sign, this one, this sign. Okay, this comma. Sign is redundant in the dataset. So first we remove it from the entire dataset and then change the data type of the numerical variable to float. Okay. So enter. Yeah. Okay. So now we will do here. So now we will see df dot head center. Why head is used? So head is used for like showing only top five rows of the data set. If you want to see the last five rows, so you can type here tail instead of head. Or what if you want to see the top 10 rows? So here you can write the 10. Okay. 0 to 9, 10. Right. So now date is changed into this and descending order, ascending order. Okay. So now we will see the duplicates. So checking duplicates, for that we have to write duplicate 0. There are no duplicate samples in the data feature. Okay. Then checking missing values. So for that we have to write df dot is null. Um, So no missing value is there. Okay. So there are no missing values in the data set. Now what I will do. So now we will visualize the gold price history data. Okay. By making graph. So here we will write figure equals to px dot line, then y equals to df dot price equals to figure dot update update, then traces, then line color should be okay, then figure dot update layout, then x axis title equals to date, comma, y-axis title equals to price, comma, then title of text. Okay, we don't require this. Text should be gold price data, then comma, y be 0.95, then x should be 0.5, then x anchor is center, then y anchor y anchor is at top. Okay. comma. Then here we will write plot bg color RGBA 255 comma 223 comma 0 comma 0.9. Okay. So as you can see the gold price data graph, okay, from 2013 to 2022. Okay, so now what we will do, we will split data to training and test sets. Okay, so there is one thing, since we cannot train on future data and time series data, so we should not divide the time series data randomly. Okay, like how much percentage to give to training set, testing set, like that. In time series splitting, the testing set is always later than the training set. Okay, so we considered the last year of for testing and everything else for the training. Got it? I'm repeating again. So here the thing is that since we cannot train on future data and time series data, okay, so we should not divide the time series data randomly. In time series splitting, testing set is always later than the training set, so that we will consider the last year for the testing and the everything else for the training. Okay, I will make a graph, so from that graph you will understand easily. Okay, so here I will write test size pursue. Okay, so test size pursue df dot date dot dt dot year equals to 2022 shape. Okay, test size. So here as you can see the test size is 260. Okay, so now we will make a graph of gold price, like training, how much is for training, how much is for testing plot. Okay, so for that I will write plt dot figure, then figure size equals to 15 comma 6 comma dpi equals to 150. Okay, then plt dot rc params axis comma h color equals to white. Okay, take, not come here, face color. Face color equals to yellow. Okay, then plt dot rc axis comma h color equals to white. To cyan, it will be good. Then plt dot plot, then df dot date test underscore size comma df dot price, then underscore size comma color equals to black, lw equals to 2. Okay, copy it for the testing set plus the red. Here, remove a small change. Now, what we will do, we will set the title and all. Title, gold price, train, and test. So, after that, uh, I will set the font size. PLT dot X label, then date, comma, font size was to 12, then PLT dot Y label, then here I will write price, font size, still we will put 12 only. So then PLT dot legend, training set, comma, test, okay, test set. Then I will like the location equals to upper left, position equals to this is size 10. Okay, then plt dot grid color equals to white, then plt dot show. So this is the graph. So this black color graph is for the training set and this red color graph is for testing set. Got it? Okay, this is from the data only, data set we have. And this is the date, price. Okay, date and time maybe I have to write here or years maybe. Okay, so instead of date, I will write here. What should I write? Year. Okay, now it's good. Year. So after splitting into the training and the testing, what we will do now data scaling. Okay, since we aim to predict price only based on historical data, so we have to scale the price using what we already know. We have like min max scaler. So we will do from that to avoid what intensive computations. Okay, so data scaling. Now we will do data scaling. So here I will write scalar equals to min max scalar. Okay, so we don't have to write again and again min max scalar. Now we can write scalar. Scalar equals to dot fit df dot price values dot d shape -1 comma 1. Okay, so min max scalar is loaded. So first I will do So now what we will do, we will restructure the data and create the sliding windows. So the use of prior time steps to predict the next time step is called the sliding window. Okay. So in this way, what we can do, the time series data can be expressed as supervised learning. So we can do this by using previous time steps as input variables and use the next time step as the output variable. So the number of previous step is called the window width. Here we set window width to 60. Therefore, xtrain and xtext will be nested list containing list of 60 timestamp prices. Okay. Now listen carefully. Y train and Y test are also list of the gold prices containing the next day's gold price. Correspond to each list in the X train and the X test. Okay. So here we will set window size equals to what? What I said 60. Okay. Press enter. Now training set. So train data equals to df dot price test size, then train data equals to scalar dot transform train data dot values dot reshape, then -1 comma 1. Okay, press enter. Now x train array, then y train. Okay, so for I in range window size comma len train data. Okay, so x train dot append train data I minus 60 I comma 0. Okay, then y train dot append train data I comma 0. Okay, so this is for the training, and now we will do the for the testing data. Test data equals to df dot price test size 60. Okay, then test data equals to scalar dot transform test data dot values dot reshape s1 comma 1. Okay, then again for the test equals to blank array, then y test equals to this. Okay, so for I in range windows size comma test data x test dot append test data minus 60, then I comma 0. Okay, then y test dot append test data, then I comma 0. Okay. For the training and the testing is done. Let me check. Okay, everything is fine. So now what we will do convert data into NumPy arrays. Okay. So the thing is that now xtrain and xtest are nested list. Okay, two-dimensional list. And ytrain is the one-dimensional list. So we need to convert them to NumPy arrays with a higher dimension, which is the data format accepted by the TensorFlow when the training the neural network. Okay. Let's start with that converting data into NumPy arrays. So we will write x train equals to np dot array x train. Okay, then x test equals to np dot array test. Okay, then y underscore train equals to np dot array then y train and y underscore test p dot array y test. Okay, then we will write x train equals to np dot reshape the x train comma x train dot shape train dot shape test equals to np dot reshape test comma x test dot shape comma test dot shape 1 train equals to np dot reshape y train comma minus 1 comma 1 then y test equals to np dot reshape then y test comma k test dot shape text shape. There is an error, so let me debug. Okay, list object has no attribute shape possible. Copy it and paste it again. Error. K test X train, X test, Y train, and Y test. Into like this. Mirror is coming. Okay, so let me debug this error. There was an error in this. Okay, so now what I will do, I will print the shape, print strain shape. Okay, comma x train dot. Let me copy it and paste it 4 times. I train test test. Okay, then here again y x test y test. First, let me do this. Okay, see, so there are like this much of rows and columns present in training and the test set. So now finally let's create a LSTM network. Okay, we will build an LSTM network which is a type of RNN, recurrent neural network designed to solve vanishing gradient problem like forecasting and all. Okay, so for that let me write df fine model. Okay, input 1 equals to input put shape equals to window size 1 equals to LSTM done sequences equals to true. Okay, then x equals to dropout 0.2 equals to LSTM equals to 64 comma return sequences equals to true. Okay, x equals to dropout dropout and 0.2 x. Okay, then x equals to LSTM. This will be 64 x, then x equals to dropout 0.2x. Okay. E is capital. Now, here I will write x equals to dense. You know the dense layer now. We discussed in the starting activation equals to softmax. Okay, then x. Then DNN output equals to dense. Then model equals to model. Inputs will be input 1 comma outputs equals to DNN output. Okay, then model dot compile loss equals to mean squared error comma optimizer equals to nada. Then model dot summary, then return model. Okay. Okay, then we have to define the model equals to define model. Okay, then history equals to model dot fit x train comma y train comma epochs will be 150 comma batch size should be 32 and the validation split equals to 0.1, then verbose equals to 1. Okay, now press enter. Okay, there is functional object has no. Okay, there is a spelling mistake. Okay, model history. Yes. Okay, it's again model dot fit got a validation. Okay, spelling mistake. So sorry for this validate. Okay, so it will be run till like 150 approx. Okay. It will take like it will 156. Okay. So it will take little time. Till 150 it will be do. Go. After this, we will do model evaluation and then we will visualizing the result after prediction. Okay. What the model will perform. It will take little bit time. It's just 17. It will go till 150. So we have to wait for this. This is all the loss and it will take the accuracy and all. It will take little bit of. Okay, 22. After this, we will at the model evaluation, we will see the, you know, the accuracy, the test map, the test loss, all the things like that. Okay. And after that, we will visualize the result, training and the testing purpose. Okay, I will get back to you when it will be done. So till like 108 it's done. Still some 42 are left. So let's wait for some more time. Okay. It will be done. Then after that we will what we will do? We will visualize the results and first we will do model evaluation and then we will visualize the result. Okay, in model evaluation, we will see the accuracy, the test MAP, the test loss. Okay, then we will predict the results. After that visualization result, like what's the actual and the predicted price values. Okay, on, on using the same chart. Then 112. You can download this dataset from the description box below. Okay. And if you need this whole code, you can comment down for the same. If you need this whole code, okay, I will make a PDF and I will put in the description box if you need this whole code. Okay, 16, something more. I hope you guys understand till here. If you have any doubt, you ask in the comment section. Okay, any sort of question regarding to Python and machine learning, you can ask in the comment section. Our expert will help you out there. Okay, 30 more. Okay, like 122. If you have any queries related to Python, machine learning, any problem in this code, you can ask me in the comment section. Okay, we will respond you as soon as possible. Okay, I will get back to you when this whole code will be done, whole process. Okay. So as you can see, it's almost done. 143. Till 150. Okay, 144. Six more. 145. Four more remaining. I hope the error will not come after this. 49. And the last one. Okay. So here we can start the model evaluation. So here for the result equals to model dot evaluate x test comma y test y prediction equals to model dot predict test. Okay. So after that I will write map equals to mean solute percentage error y test comma y prediction accuracy equals to 1 minus okay. Then here I will write print test loss, okay, comma result, then print test map print test accuracy accuracy. Okay. Okay, accuracy is not defined. Take there maybe. Okay. Yeah, here A is small, so that's why it's not loading. Yeah. So as you can see, the test map is 0.02 and the accuracy is good, like 97%, almost 98%. So let's visualize the result, returning the actual and predicted price values to their primary scale. Okay. So first I will shift like this. Yeah. So here I will write phi test true is equal to scalar dot inverse transform y test, then y test prediction equals to scalar dot inverse transform y prediction. Okay, now let's see investigate the closeness of the prices predicted by the model to the actual prices. Okay, for that here we have created the same kind of graph, so I will copy it from here. Okay, and paste it here. Okay, we'll do some color change. So instead of yellow, I need the cyan color and model performance. Okay, that I want the red. Okay, yeah. So let's see the actual. Okay, axis of phase curve C. Okay, there is cyan and it's missing. So training data, actual test data, and the predicted data. Okay, so it's black. It's black. So what I will do, I will make it green. Yeah. So training data is this, and the actual test data is this, and the predicted test data is this. So it's like predicting almost the same. So it means our LSTM model is performing good with the 97 accuracy. So as you can be seen, the price predicted by the LSTM model like follows the actual prices greatly. The value of loss and the accuracy of like 1 minus MAP obtained on the test data. So also confirm the great performance of the model. So loss equals is 0.001, accuracy is almost 98%. Okay. So I hope you guys understand like how you can do a model evaluation or time series prediction, gold price prediction using LSTM model. You can ask in the comment section below if you have any queries. Our team will respond to you as soon as possible. So don't forget to check the courses related to machine learning AI from the description box below. And if you want this full code, just comment for the same. And thank you so much for being here. If you enjoyed this video, please subscribe to our YouTube channel and give a like to this video. Thank you and keep learning.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.